Hi everyone, this is the video for your Unit 1 test review. Your unit test is on Friday, September 20th, so be sure that you're studying for that. This video will help you do so. So the test is very similar to the review. I just kind of copy and paste the test and change the numbers, so it will look very, very similar. So if you can do this, you are set for Friday, okay? So for number 1, this is about compositions and inverses. Number 1 just wants you to find the composition in both directions. So if I'm finding f of g of x, that's telling me that I'm looking at my outer function f, and wherever I see an x there, I'm going to substitute. So f of x looks like this. I'm going to replace this letter x with the entire g of x function. So instead of writing an x, I'm going to put 1/3 x minus 5. Do not stop here. Make sure that you distribute completely. So that 3 is going to get distributed. I'm going to simplify. 3 times 1/3 x is just going to be a single x. 3 times negative 5 gets me negative 15. And then I've got plus 7. So this is going to get me x minus 8. Okay. I want to find g of f of x next. So that's telling me, look at the outer function g, which is this, and it wants me to replace the x that's here with the f of x function. So instead of writing an x, I'm going to replace it with 3x plus 7. Then I'm going to distribute. 1/3 times 3x is just going to get you a single x. 1/3 times 7 is 7/3. And then I've got the minus 5. At this point, you can use your calculator if you want, but this is going to give you, if you do 7/3, 5 is the same thing as 15/3. So this is going to give you negative 8/3. Okay, so this question, you should have two things that you circle or box. It wants those two compositions. Number 2 wants you to determine if those two functions from number 1 are inverses or not. In order for something to be an inverse, you need to have f of g of x equal to just x. G of f of x also has to be equal to just x. In both cases here, these are not just equal to the single letter x. One of them has a minus 8 attached to it. One of them has a minus 8/3. So since these are both not equal to x, g and f are not inverses, because both compositions are not equal to x. On page 2, question 3 wants you to describe the type of symmetry each graph has. I gave you kind of like an answer bank underneath of where it says type of symmetry. So the answers for this are either going to be x-axis, y-axis, or origin. So you're looking for the line that would cut this graph in half. So for the first example, if I draw a line down the y-axis, it looks the same on both sides. So this one would have y-axis symmetry. For the second one, if I were to rotate this 180 degrees, this half of the graph would lay on top of the other half. So it's going to have origin symmetry. And on the third one, if I cut this in half along the x-axis, it would look the same on both sides. So this one has x-axis symmetry. Number 4, the inverse by definition means that the x and the y values are interchanged. So this first table is the table of the original function f of x. If I want to find f inverse, that means that I'm going to flip the values in the table. So 1, 1 is still going to be there, but instead I'm going to interchange 3 and 2, 5 and 3, and then I'm going to have 2 and 4. Okay, so these points on my new table that I have, those are the points I'm plotting. Okay, so your graph should look like that. You're not going to connect anything. We don't have a map of how to connect these dots, so you're just going to leave it as a scatter plot. We're going to flip. All right, number 5. This is, I know, everyone's favorite subject. When you are doing the reduced form, that wants you to cancel the same factors from the top and the bottom. So notice you've got a copy of x minus 2 on the top and x minus 2 on the bottom. Your reduced form, you're just going to rewrite this without that factor included. Okay, so that would be your reduced form. Just as kind of like a little guide to help you remember. Okay, K is the horizontal asymptote. X minus A creates the root. X minus C creates the whole. And X minus B is the vertical asymptote. The second X minus C that you see on the bottom is also the whole. Okay, so when you're looking at the reduced form, the vertical asymptote is that factor that's left on the bottom. So you have X minus 4. Whenever you're attached to an X minus something, you're always going to flip the sign, because essentially what you're doing is solving for X. So your vertical asymptote would be at X equals positive 4. So I'm going to go ahead and graph that on my coordinate plane. And since it's vertical, that means it's going to be going straight up and down, like that. Okay, state the roots. The root is the factor that's on top, so this was our vertical asymptote. This one is our root. Again, you're going to flip the sign because you're essentially solving it. When you write the root as a point, the x value is 1, and the y value is always 0, because at the x-intercept or root, the y value is 0. So you're going to plot that point 1, 0. Okay. State and plot the removable discontinuity. A removable discontinuity is just the whole. And you care about the x value of the whole, and your calculator is going to give you the y value. So this is just asking for the whole. Move this over. Okay, so the factor that you canceled on the top and the bottom originally was x plus 2. So you're going to flip the sign. So the x value of the whole is at negative 2. If you go on your calculator and you graph the reduced function and then you hit Control T, it will tell you when the x value is negative 2, what does the y value give you. Your calculator is going to tell you that it's 3 over 2. That's the same thing as 1.5. So your whole would be at negative 2, 1.5. And you're just going to label that as an open circle on your graph. It's like that. Okay. State the y-intercepts. The y-intercepts happen when x is equal to 0. So again, on that same table that you've got, you are going to hit Control T, and you're going to look for the x value of 0. The y value that it's going to give you is going to be 3 over 4, or 0.75. So the y-intercept would be at 0, 0.75. So that would be like about right here. Okay, state the horizontal asymptote. The horizontal asymptote is just the number that's in the front of all the parentheses. That number does not flip sign because it is not attached to an x minus something. So this number 3 right here, this is your horizontal asymptote. We're going to write that as y equals 3. Whenever you have a horizontal line, it's y equals. Whenever you have a vertical, it's x equals. So in this case, I'm going to draw a horizontal line across the y value of 3, and this sign is not going to get flipped because it is not attached to an x minus. Okay, so that's what your graph should look like. You will have a calculator. If you need to get the general sense of what it looks like, you can graph it on there. But remember that it's just gonna go towards the asymptotes. So this side is gonna come up like this, and go down, and this side is gonna just approach the asymptotes like this. So that is what your graph should look like. For number 6, we are given a parent function and the transform function. The first part of the question just wants you to list the domain and the range of the parent function. Interval notation is when you've got either parentheses or brackets, and then you've got 2 numbers and you've got a comma. So you can graph this on your calculator if you want to. If you graph x to the 3rd, it's gonna look like this. Okay, so for my domain, I'm looking at the x values. I'm gonna include all of the negative x values and all the positive x values. So that's gonna be negative infinity to positive infinity. For the range, I'm gonna include all the negative y values and all the positive y values. So that's also gonna be negative to positive infinity, okay? Even though all real numbers is correct, that is not considered interval notation. So on your test, please write it this way and do not put all real numbers because that's not interval notation, okay? For the transformed function, you don't have to tell me the domain and range of the transformed, you just have to tell me what transformation happened. So I'm gonna list out what each thing is. So your a value here is 1/2. The b value is 4/3. H is 2, and k is 2, okay? So if it helps you with the h, if you wanna write it as x minus 2, that might make a little bit more sense to you, that's okay. The a value is smaller than 1, so that means you have a vertical compression or shrink of 1/2. So with vertical changes, if a is bigger than 1, you have a stretch. If a is smaller than 1, you have a shrink, and you're stretching or shrinking by the original number that you see. The b value here is bigger than 1 because the top number of the fraction is bigger than the bottom. That means that you have a horizontal compression. So the conditions for vertical and horizontal are flipped. And you're gonna compress by 1/b. So, sorry, the video cut off. You're going to flip your fraction. So this is going to become horizontal compression of 3/4. So you're gonna look at the b value first and tell me what it is. And then after you know what it is, then you're going to flip the value that you get, okay? H, that's going to move us to the right 2. If you have x minus something, you move right. If you have x plus something, you move left. The k value is positive, so that's gonna move us up 2, okay? So the answers that I'm looking for are these things that I'm outlining in blue. Let's look at end behavior. So I highly recommend that you sketch out what the graph looks like first. If you want to graph it in your calculator and sketch, that's fine. I'm going to do it by degree and a value. So for number 7, the degree is your highest exponent. Your highest exponent here is a 4, and 4 is an even number. The a value, or also called the leading coefficient, is the number in the front, so it's 5. And 5 is a positive number. So the degree is going to tell you even or odd. So is my graph pointing in the same direction or different directions? And the a value is going to tell you, is it positive or negative? So am I going up or am I going down? So just to kind of sketch this out, since our degree is even, that means both ends of my graph are going to go in the same direction. Since 5 is a positive number, that means both ends of the graph are going to go up. So my graph is going to look like this. So when I'm listing my end behavior, as x is going towards positive infinity, means you're going to cover up the left half of the graph because you only want the positive x values, so I'm looking at the right half. That half goes up towards positive infinity. When I'm looking as x goes to negative infinity, you're going to cover up the right half and just look at the left. That side also goes up towards positive infinity. For part B, we're going to do the same thing. So my degree here, my highest exponent is a 3, and 3 is an odd number. My a value is -2, and that is a negative number. So odd means that my graph is going to go in 2 different directions, and a negative a value means that the right half of the graph is going to point down. So if the right half is pointing down and I'm going in different directions, that means the left half should be pointing up. So as x goes to positive infinity, I'm going to cover the left half and just look at the right. The right half of the graph goes down towards negative infinity. As x goes towards negative infinity, you only look at the left half of the graph. The left half is going up towards positive infinity. All right, number 8. We went over this one in class, but just to kind of reiterate, when you have c of 2, that's asking you when t is equal to 2, what is the y value that you get out, okay? So I would recommend you graph this in your calculator and then hit Control T, and it will give you the y value. So the value that it gives you for c of 2 is 3.53, and the units on that are mg over dl. They give you the units up here. What it means in words is the concentration of medication after 2 hours. Because your T is 2, so that's talking about time, so 2 hours. C of that represents the concentration in the bloodstream. So the patient has 3.53 milligrams over deciliters of the concentration in their blood after 2 hours. This one asks when the concentration is the lowest. If you graph this on your calculator, my graph is going to be like super ugly, I'm sure. I don't even know if this is, yeah, whatever. So it looks something like that. So concentration being the lowest, we can't have negative time. The x-axis represents the amount of time, and the y-axis represents concentration. So I'm not even going to look at the left half of the graph, I'm just going to look at the right half. The minimum of that right side is at 0. So when t is equal to 0 is when I have the lowest concentration. Your test is going to ask you for the highest concentration, and in that case you're going to be looking at the maximum. The maximum happens at 5.43 or something like that. I could be totally wrong. No, 5.48, sorry. So at 5.48 is when it's the lowest. So you would say after 5.48 hours for your test. Okay, but for the review, it's going to be at 0 because it's the lowest. All right, for part C, we want to look at increasing and decreasing intervals. So again, I'll kind of draw my ugly sketch of the graph. Okay, so your graph is, that's actually really bad. Sorry, it's going to look funky if I don't draw it right. Okay, that's a little bit better. So your graph is decreasing where the red arrows are. Okay, so I'm decreasing all the way from negative infinity until the minimum, which is at negative 5.48. Then I change direction and I start increasing, and I'm increasing all the way until positive 5.48 or the maximum. And then I continue decreasing on. Okay, so your decreasing is going to have a jump in it because the center interval is increasing. When I'm increasing, I'm going from this point to this point, going up. So your increasing is going to go from the minimum, negative 5.48, to the maximum at positive 5.48. We're on the last page. Awesome. The piecewise functions, I think a lot of us struggle with those the most. So the first thing you need to do is draw boundary lines. So let's look at these two domain restrictions that are here. Okay, so I'm gonna have a boundary line at -2, and I'm gonna have one at +1. Okay, so after you draw your boundary lines, you need to graph the function. So I'm gonna do this one in red. So for the red equation, my y-intercept is at 2, so I'm gonna go up 2 on the y-axis and put a point. Let me erase that. Oh my gosh. Okay, from that point, my slope is 3, which means that you're gonna rise 3 and run 1. And I'm just gonna do it within the bounds of the interval. You can also go down 3 and left 1 and get the same effect. If you would like to go outside of the boundary lines and then erase, that's fine too. Okay, so here's my line. At that value of -2, notice that your circle, or your inequality symbol does not have a line under it. So that means on that part of the boundary line, you're going to have an open circle there. The other inequality symbol does have a line under it, so that means that dot is going to be completely filled in. Okay, so that's one part of your piecewise. I'll do the other one in green. Your y-intercept there is at -1, and your slope is 1/2. So that means you're gonna rise 1 and run 2. You can get the same effect by going down 1 and left 2. Okay, I'll do a couple more points. All right, so I'm gonna connect these. All right, what part should I erase? So the inequality says that if x is less than or equal to 2, so I'm gonna go, or -2, so I'm gonna go to my boundary line of -2. That point should be closed because there's a line under it, and I want all of the x values that are less than that. So anything that's to the right of that line would stand for x is greater than, so I'm gonna erase all of that. Okay, so my line is gonna start at the x value of -2, and then it's gonna go down towards the left side of the graph. So that should be what your graph looks like. For the domain, remember that you're looking all the way from the left to the right. So in interval notation, I have all the negative x values that are included because the green arrow means I'm gonna go all the way in the negative side. The next break in my graph happens on that boundary line of -2. Notice you've got an open circle and a closed circle on the same x value. So your closed circle is your safety net, so it still is continuous at that point. There's gonna be no break, so I don't need a union. So I'm going. My next break happens at 1, and then my graph just kind of stops there, but it is a closed circle, so I'm gonna put a bracket. The range goes from the bottom of the graph to the top of the graph. So because of that green arrow again, I'm gonna hit all of the negative x value, or all the negative y values. Then notice you've got an open circle on the red graph, and then you've got the green graph across from it, okay? So since you have a piece of the graph that is still across from the open circle, there's gonna be no break because that graph is coming in to save or be the safety net for the open circle. So we're gonna continue. The highest point of the graph up here is at the y value of 1, 2, 3, 4, 5. And there's a closed circle there, so I'm gonna put a bracket. Okay, number 10. So I want you to first figure out the degree and the number of turning points because everything else will kind of follow from there. So the turning points are just the highs and lows that you see. So here's a high, here's a low. So I have 2 turning points. The degree is always the number of turning points plus 1. So if I have 2 turning points, that means my degree is going to be 3. So whatever number you have for the degree needs to be 1 more than the turning points. Okay, so your degree is the same thing as the least possible degree. It's just a different way of saying it. 3 is an odd number, so this is going to be an odd degree. The right half of the graph is pointing up. That means that your leading coefficient or your A value needs to be positive. Okay, the number of real zeros is asking where are your x-intercepts. So your x-intercepts are just where the graph goes through the x-axis or touches the x-axis. I don't want you to be specific, this is a single root or a double root or whatever, okay? I just want to know where it crosses. So I've got a point here and I've got a point here. So that means that I've got 2 real zeros because I touched the x-axis 2 times. The y-intercept is where the graph crosses the y-axis. You only have one point where that happens, and that's right here at the origin. That point is 0, 0. So that's my y-intercept. For your end behavior, that's where you're writing it like this. If you are taking your test and you forget how to set this up, go back to problem number 7 because I wrote it out for you so you know how to set it up, okay? So it's going to start out like this. I need to fill in the blanks here. So as x goes towards positive infinity, means you're looking at the right half of the graph. The right half of the graph is pointing up towards positive infinity. As x goes to negative infinity, means you're looking at the left half of the graph, and the left half goes down towards negative infinity. Okay, so please make sure that you are studying for your test. This is going to make or break some of you, so please, please, please study. If you need me, come in on Thursday. I won't be here Friday morning, so come see me on Thursday after school if you need help. Happy studies, and I'll see y'all today in class.